Hello as always. Welcome to our specific heat lab. Now in this lab, what we do is we make use of the equation Q is equal to mc delta T, or MCAT. M is mass, C is the specific heat capacity of the compound or object being studied, and delta T is the change in temperature. Technically change in temperature in Kelvin, but since change in temperature in Celsius is the same thing, we just use Celsius. And Q is heat. Now, when you use a calorimeter, which has basically an adiabatic walls so that heat is not entering or leaving the system, at least in negligible amounts if at all, we can say that if one object gains heat inside of this chamber, another object loses the same amount of heat. In other words, Q is equal to Q, or mc delta T equals mc delta T. So water becomes one of our systems, and we'll measure the mass of the water. We know the C for water is 4.186, at least at regular temperatures. It actually can be a little bit lower or higher depending upon the exact temperature, but we're going to average it out at 4.186. And then we're going to measure the change in temperature. So we're going to know mc and delta T for the water. Into that water, we're going to put a heated piece of metal. We will know the mass of that metal, and we will calculate the change in temperature of that metal. But we won't know the C of that metal. So basically, you will have mc delta T equals mc delta T, with one of them being ice or water, and the other one being the metal. And the only thing you won't know between those two will be the C of the metal. Now, right off the bat, I've already done some measurements. We have a piece of metal, and you'll see it in the images in the videos about how big that metal is. It's about 38.83 grams. The calorimeter cup is 142.98 grams, to which I added water, and it then weighed 261.52 grams, meaning that the mass of the water, which is just the difference between those two, was 81.46 grams. Now what I'm going to do is I took the solid and I put it in boiling water or heated water, and I took the cup and I added like 1 cube of ice to it to cool it down. So I did that, and let's look at some videos to show us exactly what happened. So here is my water that I'm boiling. I'm trying to heat it up, and it took quite a while. I mean, it takes about 10 minutes to get this water boiling because I don't want to add salt or anything to it. Although I guess it doesn't really matter, but I don't really care where it boils. I just want it to boil, and I'm using a low heat here so that it heats generally pretty slow. So this heats for a while, and then for a while longer, and it keeps heating. And I'm going to bring that up. And in this experiment, it started to boil, and I have found that in my classroom using tap water and using my thermometers, I always get about 98.0 degrees Celsius is where water boils. Now we're not at sea level, but it should be a little higher than that. I'm not really sure. I could add a little bit of salt to it to raise it a little bit, but we're going to use 98.0. So the initial temperature of the solid will be 98.0 degrees Celsius. So that's what you're going to put there as your initial temperature of the solid, 98.0 degrees Celsius. Now this is the initial temperature of the water, and you'll see that it's almost exactly between 10 and 11. So we could say 10.5, maybe a little bit above that. I think when I did my calculations, I'm pretty sure, yeah, I'm looking over here, I used 10.6 is what I used. So I used 10.6 as my initial temperature of the water. Now that chamber looks basically like this, and you'll see it again over here when we get to it. From the top, here you can see what that chamber is. It's just a calorimeter with sort of a thermal adiabatic wall, which is basically a thick styrofoam between two pieces of light metal. There's a thermometer sticking in it, and this little gray thing to the bottom there is a stirring rod, kind of to churn it a little bit. And if you want, you can hook electrodes up to the bigger area. So that's our calorimeter. So now we go back to the water, and you can see it's boiling now. And if you look at the right, you can see a little piece of cord hanging out of that. And in that cord, it's connected to the metal. and it's heating up to about I know it's not quite there yet. If you look at the thermometer, it looks like it's about 96 degrees. So I let that boil for a while so that we can kind of see about where it is. And it's still going up. Even though the water is boiling, it's not quite yet at 98. So I let this go for a little while, and I'll skip ahead to where I'm ready to pull it out. All right. So the first thing I do is I turn off the gas when I feel like it's about there, and then I'm going to quickly dry the metal off. So I'm going to take this metal out and quickly dry it off because I want to get rid of all of that hot water because I only want to transfer metal into the chamber. So I'm going to dry it off as much as I can. It's pretty hot. So I do it rather quickly, and then I put it as quickly as I can into the calorimeter. And I'll fix the angle of the video and everything in a second. It'll focus. So now everything's in the calorimeter. And I churn up and down just a little bit. I don't want to add too much kinetic energy to the water. And I noticed that the thermometer was turned a little bit, but it was a little too late to fix that now that everything's in there. So now what we do is we just sit and wait. And the temperature of that water is going to go up, but not by very much. Now, if you remember, the metal started out at 98.0 degrees Celsius. And the water started at 10.6, but water has a huge heat capacity, and metals are usually about 10% of that. So we're going to watch this temperature go up, and you're going to see that it's going up right now, and you can kind of read it there. It's a little blurry for you guys. I waited a little longer for it to go up, and I'll fast forward to that point. But in my estimates, and I'll just give you this number, the final temperature of the solid, the cup, and the water was about 11.8 degrees. I think I get it a little bit more focus here towards the end. There. 11.8, if you think it's 11.9 or a little lower than that, you can see right there for a second I got it really good and focused. So I have a final temperature in my calculations of 11.8 degrees Celsius. So starting temperature of the metal, 98 degrees. Final temperature of the metal, 11.8. Starting temperature of the water, 10.6. Final temperature of the water, same as the metal, 11.8. Okay. So we now have an initial temperature of solid, initial temperature of the cup and water, and a final temperature. And from those, we can calculate the changes in temperature. So we can know what the change in temperature is here. Since I went ahead and gave you these values, you don't have to use 10.6. You can use a different temperature if you want, if you thought it was a little bit different. And you're going to see that it's going to be fine. Then we have a final temperature of the solid cup and the water, and the final temperature was, wait, no, I did that wrong. The initial temperature of the solid was 98.0 Celsius, and the initial temperature of the liquid was 10.6 Celsius, and the final temperature was 11.8 Celsius. And remember, Q is equal to mc delta T. So calculate the temperature changes, then calculate the joules gained by the water. Q is equal to mass of the water times the change in temperature of the water times the specific heat of water, which I told you is 4.186, and that'll give you the joules gained to water. The joules lost by the metal has to be equal. So you don't even have to do a calculation there. It's going to be the same as the number above it. It has to be equal. And I don't know if I ask you that as a question. And then you have to figure out, okay, what is the specific heat of that metal? What is the C of that metal? If Q, which is this value, is equal to mc delta T, and you know C, and you know Q, you know M, and you know delta T, you can calculate C. Knowing C, and you should get a value, I won't tell you what the value is, but you should get a value really close to the value for lead, because that's a lead bobber. There's a little bit of cloth attached to it, which will affect it a little bit. But but you should get a value somewhere, and lead's specific heat is 0.13. 0.13. So don't try to fix the number so that you get exactly 0.13. You don't want to get the exact number. That just tells me that you like went backwards or cheated or something. You want to put the value that you get. You're not going to get it wrong as long as you use these numbers and get a value that you should get. So now you have to answer questions. Why is it desirable to have the water a few degrees colder than room temperature? Think about what happened, think about what could happen, and try to answer that. I don't want to give too much away there. Why should the hot metal be dry before it is introduced into the cold water? I already told you that in the video. Why is the heat gained by the water equal to the heat lost by the solid? Think about our system. And I told you what kind of system it is, and you can answer that. There's actually a word that starts with the letter A that explains why that is true. What do you think is the identity of your metal? I already told you it is lead, but can you tell me, like, after you do the experiment, if you were to calculate the specific heat of your solid and knowing the specific heat of lead, would you think that your solid was lead, or would you maybe think it was something else? But also take into account that you can see it, you can feel it, you can look at it. You know, you kind of have an idea that it might be lead even before you begin. But why do you think that? Give me at least one good reason for why you think it might be lead. And then finally, what does, I don't know if this is, I think it's finally, yeah. What does this experiment show about the specific heat of water? And I'll give you a hint. Water only changed by 1.2 degrees Celsius. The solid went from 98 down all the way to past 12. That's a change of, what is that, 86.2 degrees. That's a huge change in the temperature of the solid versus the temperature of the water. Answer those questions, turn it in online, or if you're doing this in class, turn it in class, and there's a whole lot of text here to kind of explain what I did. I may have made a few changes as I was doing it, and then some answers here about how you can answer some of the calculations. Okay. Now what I want you to do is on this part right here, that's where I want you to write your calculations if you need it. So for these white cells in the third column, or I guess fourth column, I want you to write what equation you used to solve for those values. And you don't need to worry about trial 2. Since we're doing this online, I just did one metal, one trial. And if you have any questions, let me know. Have a great day.